Good afternoon, everyone. My name is Sandy Ibrahim, and I'm an applications engineer at CAMufacturing Solutions. Today, I will be presenting this presentation that applied along with my colleague Hamoon Ramazani. So just as a reminder, some of our live streams that we'll be having tomorrow are as follows: Making Hybrid Manufacturing That Easy, Part 1 and Part 2 at 10:15 a.m. and then 12:15 p.m., followed by a deep dive panel discussion with some of our researchers at CAMufacturing Solutions, talking about some of the research and how we intertwine it with our software A+ at 2:30 p.m. And then a session at 3:15, an educational session at 3:15 p.m. by the president of CAMufacturing Solutions, Bob Hedrick, coloring with a big crayon. And finally, this session repeated again tomorrow at 4:30 p.m., DED Applied. So the agenda for the following session is a quick introduction on DED and basically how it applies to the different case studies that we'll be showing today. The first case study, mold customization. Second case study, build a T-connector. Third case study, repairing a blade. And finally, building a U-drill with a through-tool cooling. So what is directed energy deposition in additive manufacturing? Directed energy deposition, also referred to as DED, uses a direct energy source to melt and fuse deposited materials. And there are typically four types of heat sources that can be used for a DED application: a laser beam, an electron beam, a wire arc, or a plasma arc. And the following here is a short video from one of our industrial partners in Italy called Prima Additive, using their Laserdyne 430 machine to show a laser head melting and depositing powders onto a substrate. So onto our first case study, mold customization. So basically, mold customization is referring to just a basic mold. As you can see on the image to the left, just an empty mold where we want to customize and print a logo onto that surface. So we use the logo of our software A+ to print onto that mold. And the following video will show the steps of how we achieve that. So here, this is the first additive process using directed energy deposition on our software A+, and it just shows the different stages or the simulation of the additive process of how whichever logo is chosen is printed onto the surface of the mold. And then this is followed by AM part model. So AM part model is used to show the different layers and to view whether the user is happy with the fill pattern of the surfaces. So you can get a clear view of each layer. And then we have the A+ virtual machine here, and this is used to simulate the machining process after we've done the additive parts or within the additive parts. So here we have two different machining processes. So the first one, just flattening out the top layer, making sure that it's all flat and nice, and then trimming the edges of each layer as the second machining process. So this is how A+ also incorporates hybrid manufacturing. So it's using both an additive process and a machining process in one part to achieve like this final outcome, a logo on a customizable mold that uses initially additive manufacturing and then that is machined off using machining techniques. Our second case study is building a T-connector. So these are just the different steps that, again, show how we can use hybrid manufacturing in our software. So we start with an initial machining process, followed by an additive process, and finally a third machining process. And in the following video, we'll go through the different steps of how each of these stages is achieved. So this is the start product, and this is the final product over here. So the following just shows the initial workpiece of a part that would have used subtractive manufacturing and how it's much bigger than using hybrid manufacturing to build the same part. So there's a lot less material wasted if we are to use hybrid manufacturing to build a T connector. So the first stage using hybrid manufacturing, we're using a bar stock and we are machining it off to have the base of the T connector. And that is followed by additive manufacturing to build the head or the T-shaped part of the T connector. And then finally followed by machining to machine out all the edges. And again, this is the virtual machine that we use to simulate the machining processes that we have in this part. So the initial machining process is using the bar stock that we have as an initial workpiece, and the initial or the machining process used to trim down that bar stock is this can be seen in the following videos. So this here is the final part that we achieve after the first step of machining. And then we take this part for our second stage for the additive process. And here, this is a simulation of how the additive process would look like on our software A+, and how we're or how we're additively manufacturing the top head of the T connector here on the lower part that was just machined. And then again, this is followed by an AM part model showing the different layers so that the user can see if they're satisfied by the deposition or how each layer looks like. And then finally, this is followed by the final machining process, just clearing the edges, trimming down everything, making sure that the final part looks good after the additive manufacturing, yes. And this is actually the final part that was manufactured using the different stages of the hybrid manufacturing process, the machining, the additive, and finally the machining again. So as a reminder, again, these are the live streams that we'll be having tomorrow in our booth, and as part of a panel discussion as well. Now I'll pass this on to my colleague Hamoon to continue with the rest of the case studies.
Thank you very much, Sandy. So we are going to continue. As Sandy mentioned, don't forget to join us tomorrow. We will have making hybrid manufacturing that is in part 1 and 2, and we will have the DED deep dive panel discussion at 2:30. Our president, Bob Hedrick, will have an educational session called Coloring with a Big Crayon, building parts quickly using hybrid manufacturing. And then at 4:30, we will have the same presentation. So to continue, we're going to talk about another example, which is repairing a blade. We know how expensive the blades are, and how DED and A+ can help you in order to repair a broken blade instead of making a new one, which would cost a lot of more money and time. So this is an example of a broken blade. So in order to fix it, we need to have a closer look at the broken edge. So if you have a broken edge like that, the first step to fix it by hybrid manufacturing is to machine the broken edge, get a smooth surface in order to deposit material. The next stage is the additive part, that we build the broken edge again by using DED, directed energy deposition. So while doing hybrid manufacturing, we will always add a lot of more material in order to do a surface finish and get a smoother finish, which is the last step. And finally, you will have your blade fixed. So now let's take a look at the video to have a deeper look on how that process was done. So this is our broken blade. This is the machine simulation of the initial machining. It's just a very simple machining on the top surface in order to have a smooth surface to work on it. Then you can just use A+ to program a toolpath and just complete that broken edge by depositing material. And again, as I mentioned, you will use extra stock, and then you can simulate that extra stock, which is compatible with Mastercam and can be used as a stock model for the final machining, as you can see. While you do the final machining, you will have the plate fixed with just 3 steps using A+ and DED. So now let's move to the next example, which is building a U-drill with true tool cooling. So we know that when you have a true tool cooling, it's not possible to make it with the traditional one. It's way easier to just build the part from scratch using hybrid manufacturing. So in order to do so, I'm going to show you a video where we use A+ and Mastercam in order to build this U-drill, do some final turning, and finish machining in order to have the final product. So on the left, you can see the design. On the right, you see the additively built simulated part. So this is the backplot of our toolpath, how we make the actual U-drill considering the true tool channel inside it. We just build the part going up. We just make it faster, but you can see every single layer of how the material will be deposited. And then you can use A+ AM part model, which is a great feature to simulate every single layer to see how the bits are deposited. If you have any worry, if you're not happy with your toolpath, you can just go and change it. You're going to make sure that you have the channel inside it, right at the dimensions you want it to. After that, we will do the finish turning on the U-drill for outer surfaces. And then it's the time for the final machining for the floor. So as you can see, the final machining, it's simulated in Mastercam Markset. So one of the great features of A+, as I mentioned earlier, is AM part model, because not only it will simulate the final part that you will have after doing your DED, it also shows you every single layer and every single bead on those layers. So you have complete control on what you're doing. If it's not what you desire, you can change it. There are lots of parameters there that will help you to get the best possible solution. And the other good thing about that is it's completely compatible with Mastercam. That means you can use it as a stock model, as you can see, and you can see how your material is being removed at the end in order to get your finished product. Also, there, as we mentioned on this presentation, there are very different areas that DED and hybrid manufacturing would help people in different industries in order to build parts or just repair them. So please don't forget to join us tomorrow for our presentations and also our research panel, and moreover, the educational session with our president, Paul Pepper. This is the schedule for tomorrow. We start at 8 a.m. We will be in the booth. We will see you at 10:15 for the first presentation. Don't forget to check our website or send us an email to contact@camufacturing.com. Thank you.